Hello, folks.
Hello, YouTubers and friends. It's me again. We're here at Boomtown Laboratories in Louisville, Texas. Now, the last couple of videos I put on a week or two ago were clips that I made while I was in Missouri with Shaziz, Tyrone Rawlings. His YouTube username is Shaziz, S-H-A-Z-I-Z-Z. Well, Shaziz and Scott Brown, Muddy Mudman, kind of got me interested in electronics. And I don't know the first thing about it, but I'm like. Anyway, what Shaziz and I were doing up in Missouri is we were lighting burnout fluorescent light bulbs with a Beckett oil burner igniter. Well, the one Shaziz has is 12 volt input, 20,000 volt output. This one is, I acquired this a couple of weeks ago. I've been playing around with it. And this one is 110 volt input. Okay. Since then I've acquired another one. So I've got two 110 volt input Beckett oil burner igniters. And I just, the day before yesterday, acquired a 12 volt input. I haven't had time to even take it out of the box other than just to look at it. And but I'm going to play around with it a little bit too. The one thing I want to, the reason I'm trying to make this video is you saw in the other videos with Shaziz, we were lighting burnout light bulbs. Now I've got some light bulbs here that are they're really small. They're newer ones, and they're not big fat ones. I hooked a bunch of them up in series, and half of them lit, and a bunch of them didn't. Some of them almost did. I don't know what the heck's going on. So I figured, okay, well maybe I got some bad bulbs, because I mean, when the bulbs will burn out, they'll still light up with the Beckett oil burner igniter. However, if they leak, if they've got a crack on the end or anything like that that you can't see, and they leak the gas out of them, then they don't light up. So I went through this morning all of my small ones that I have in the shop here, which is about let's see, about 25 or 30 of them. Anyway, out of all of them, I found 4 that were really bad. Oh, 6. Wait, 1, 2, 3, 4, 5, 6. Yeah, 6 that were bad, would not light at all, and then I have 4 that are questionable. They light, but the prongs on the ends are really loose on one end, and you can wiggle them around a little bit. So I put them in a separate pile, and all those that lit up really good, I saved. Now, as I was going through checking them out, I also had my watt meter, and that's what I was using for my power supply, drop cord and watt meter. And all of them that lit up really good, they ranged from anywhere from 13.2 to 15 watts, each bulb individually. Now here's the interesting part, okay? When you put them in series, it takes more wattage, but you would think if 2 bulbs were taking 13 watts to run, that, I mean, one bulb was taking 13 watts to run, and you had another one the same thing, that you would imagine they would take 26 watts to like 2. Well, no, it doesn't. That's the amazing thing that I can't understand. If there's somebody out there knows, then please make a comment on the video and tell me what's going on, because the more bulbs you put in series, the less watts per bulb it takes. For example, I lit one bulb was 13 watts. I lit 2 bulbs, and it took 16.5 watts. 3 bulbs took 20 to 21 watts, and 4 bulbs took 24 watts. Now, if you divide the number of bulbs into the watts, each time you add a bulb, it takes less wattage per bulb. Okay? So, anyway, I'm going to fire these up right now just so you can see it going. They're already wired up in series. Here's my starting point right here. Okay, that goes to the oil burner. The oil burner. Whoa. I'll put that down here so people can see it. Now, Shaziz and I were taking and hooking up to one side of the oil burner igniter, and the other end we were plugging into the ground. I have not done that yet. I know it does work, but I'm just going off both sides of the oil burner. So this is my inside over here. This is coming out the tail end over here, right there, and it's all hooked up. So now I'm going to plug this puppy in. Oh, by the way, one of the features of this that I found by accident this morning as I was testing, the insulation on most electrical wiring is rated at about 600 volts. Well, when you start messing around with 20,000 volts, then you got a situation here where if the wire, even the insulation even touches a piece of metal, that let's see, I gotta get this straight. If the wire touches, the insulation touches a piece of metal, it'll arc through the wire. Okay? So, let's get this, help me hook that back. Okay. Anyway, it arced through and it burnt a couple of my leads into. So, let's crank this bad boy up and let you see what's going on. All right, right now, I've already reset the watt meter and it's set at 0. So now let's plug it in. There we go. You can see they're burning almost at full brightness, which that to me is a little unusual because the times I've done tests in the past, they didn't do that. But this morning, for some reason, they're all lighting almost full brightness. And right now, we're at 23.3 watts, burning 4-foot fluorescent light bulbs that normally take 40 watts a piece. That's 160 watts worth of light for 23.1 watts right now. Okay? Now, as quick as I can without boring anyone, I'm going to turn it off and try to put another light in so you can see that what it does at 5 lights. Okay? Here we go. Now, hook this one up and we now have 5 lights. Now the wattage is going to increase, but less than the other. 23.1.2 watts is, for 4 lights, is just under 6 watts per light. Well, we now have 5, so let's see what happens now. Oh, make sure the wires aren't touching each other or anything like that. Here we go. Let's reset the meter. Okay, meter's reset. Here we go. We'll plug her in. Okay, now that's 5 lights. Oh, I lied. I don't know what's going on here. It's at 27 watts. Well, yeah, it is. Okay, 27.2. Can y'all see that? 27.2 watts. Okay? That's 27.3.2. Fluctuation in the current. That's normal. Okay, so the wattage actually increased. Now, we're saying 23.2 divided by 4 is just under 6. So our wattage use increased by 3. No, by 5, because it's now 28.2. So you can see it's actually less per bulb. It's 28.3 right now. Okay? See that? If I let it burn for a little while, most likely it will drop just a little bit as the bulbs warm up. But the thing is, they're not even, actually they feel cold to the touch. That's probably because of my air conditioner running over there. But anyway, you can see what's going on. I'm going to hook up one more light and then we'll end this video because I've got a couple other experiments I want to play with first. Okay? I just wanted people to see this. It's amazing. The more lights you put in line, the less wattage per light it takes to light them up. Let's do one more light, okay? All right. By the way, remember now, I didn't show you just one light, but I've told you, and I don't lie in experiments like this. There's no point to it. Okay. Now we have 1, 2, 3, 4, 5, 6 lights, all hooked up in series. We're going to reset our watt meter again to 0. No. Okay, folks, there it is, set at 0. And we're going to plug her in. Now, reading 31.3.4. It's setting that for 32. Like I said, when you first plug it in, it goes haywire. Then after a while, it calms down. Okay, she's at 32.3. That is exactly 5 watts above the last measurement, but with one more light. So at 32.3 divided by 6 comes out to just barely over 5 watts. Now you've got to keep in mind, I tested each one of these lights individually this morning, and some were running 15 watts, very few. A lot of them, most of them, over half were running about 14.2 watts. The rest of them were running at about 13.2 to 13.4. But you can tell right now this is nowhere near 13 or 14 watts per light. 6 times, well, say 15 watts. 6 times 15 is what? 75, isn't it? Or no, 90? Yeah. 6 times 15, yeah, 90. So in other words, we should be running 90 watts to light these lights. And you can see they're almost at full brightness. In fact, let me step over here and just turn the lights off, the overhead lights off, for just a second. And you see just how big or bright they are. Look at that, folks. That's almost full brightness. By the way, just for a lark joke, yesterday I had my brother-in-law pick up a little 12-inch by 4-foot solar panel I have. It's a 15-watt solar panel, and it was kicking out 16 and 18 volts. However, the wattage, the amperage was so low I couldn't even get a reading on it. But I mean, I didn't expect to. But the thing is, Shazizz is after voltage without amps and watts, or very little. Now, temporarily, he wants to play with high voltage. This is a way we can play with some really high voltage. Okay, because solar panels are DC output, which means we can put sandwich these lights between 2 solar panels and then hook them in series, and we can just, as many solar panels as we got, and just take the voltage way up. Okay, that's enough of this video. In the words of my good friend Shazizz, peace and love, everybody. Bye. Okay, folks, I want to add this little short clip in with this video I'm making. Off camera, I added more lights in. I now have 10 The only reason I don't have more is I've ran out of jumpers. I've got to go get some more. But anyway, we've got 10 lights, and she's running right now, if you can see that, 47 watts. That's 4.7 watts per light bulb that normally, if you light them one at a time, take 13 to 15 watts. I keep saying the more lights you put in line, the fewer watts per light bulb that you need. But 47.3 watts for 10 light bulbs. Divide it out. I mean, that is absolutely amazing. If anyone out there knows why this is doing that, please, for heaven's sake, tell me, let me know. All right, one more time. I'm just going to flip the lights off just for a split second so you can see how much you got. That's a lot of light, folks, for no more electricity than we're actually using. And that's real stuff too, real time. Holy cow. Again, folks, peace and love to everybody. Figure this out for me.